Welcome to today's session on the setting up of the PB, the 840, which is a ICU grade ventilator. All right. So before we start, make sure that the ventilator has already been powered, has been connected, and there are also the two oxygen holes that you need to connect. One is connected to the medical gas, and the other is connected to the oxygen host. All right. And I will now demonstrate how to put in the different components onto the ventilator. The first is actually the expiratory filter. All right. There is a lever at the side. First of all, you need to lift this up, align the filter in so that it fits smartly into the container, and then push the lever down and make sure that the filter is actually secure. The second component is actually putting the inspiratory and expiratory limb, which is connected to a wide connector. All right. One component will be the inspiratory limb. There will usually be a bacterial filter that comes together with the inspiratory limb. This will be applied to the inspiratory inlet. The second component will be the expiratory inlet, which will be connected to the valve. Make sure that the connections are tightly screwed in. The circuit usually comes with a cap, which we'll leave it on at this moment. Here we'll do a demonstration for the short shelf test before we connect this mechanical ventilator to the patient. Before we do this step, we must make sure that the inspiratory as well as the expiratory circuits are connected. The power plug is plugged in, as well as the gas supply is connected. For this SST, we need to also be aware of the button that we need to actually press when the option for SST is shown in the circuit, which I will demonstrate later. Before we proceed, remember to remove the cap from the circuit wire limb before we power on the switch. After the welcome screen has been shown, you will have an option for you to perform the SST. So when that button is pressed, I will at the same time activate the test button at the side, which I have shown to you earlier. It has now come to the SST setup screen. We need to select the type of circuit. For this particular demonstration, we are using a adult disposable circuit. Humidification type, which will be using a heat moisture exchanger for this demonstration. Please note that in the bottom right hand corner, there are instructions that will guide you step by step for the procedures that need to be done. Once we are selected the options, press accept, and then it will show you the SST status with the various steps that will be done. Here it's asking us to connect the circuit with the inspiratory filter and without the humidification system, which we have already done so using the bacterial filter. Press accept, and it asks us to now block the Y. So reconnect the blue cap to the Y connector before you press accept again. The whole process of the SST will take about 5 minutes to complete. During this process, it will do multiple steps to check the sensor, the circuit pressure, presence of any circuit leak, checking the health status of the expiratory filter, as well as calibrating the circuit in resistance and compliance in the last few stages. As the process continues, you will hear a lot of noise as well as pressure change occurring from the ventilator. This is the normal process, do not be alarmed. The next step would be to connect the humidification if applicable. So for this demonstration, we are using a HME device. Connect the humidification filter into the system, and then press accept. The next step the instruction is to disconnect from the patient port. This is where you disconnect the expiratory limb from the expiratory valve. Once that is done, press accept again. When that is completed, it will ask you to connect the expiratory limb back to the expiratory valve. Make sure that it's snugly tightened. Press accept. So it's now instructing us to unlock the Y connector. So remove the blue cap, press accept. We're coming to the end. So now it's asking us to recap the Y connector. Once that is done, press accept. Okay, it's now asking us to remove the block Y. And you will see that they have said that the SST testing is complete. And you will also notice that for every step, there will be a task remark. When that is done, you are ready to proceed to connect the ventilator to the patient. Right, just to note that for PV, the 840, before we start the patients on the mechanical ventilation, we need to make sure that the circuit is not connected to the patient before we switch the ventilator on. So the power switch is actually located at the center of the unit. There will be a short welcome screen as the ventilator boots up. And at the beginning, you'll notice that there will be three buttons for you to select. We've already done the SST, assuming that this is a new patient that we are going to initiate the patient on. So we just press the new patient. So when this is connected, the first thing that it will tell you is to actually key in the patient parameters. The important parameter is the patient's weight, and this weight is actually the ideal body weight, and this is based on the patient's height as well as gender. Assuming that this patient has an ideal body weight of 70, you can press the button and you can turn the dial to actually select the value that you want. You also note that once this is selected, other options will come in, and these are the options that actually allow you to select whether you're going to put this patient on invasive mechanical ventilation or the non-invasive mechanical ventilation. For the purpose of the demonstration today, we are going to select invasive mechanical ventilation. Depending on the software that comes with the machine that you have, you will see that there's various modes that you can actually regulate how the ventilator delivers the breath. And for this particular machine, there's assist control, synchronized intermittent mandatory ventilation, or SINV. There's a spontaneous mode of ventilation, which is a pressure support ventilation, and you can also do bi-level ventilation. So for this demonstration today, we will be choosing the assist control. And you can actually regulate the breath either using volume control or the pressure control. And there's an additional options of volume control plus, which is the equivalent of pressure regulated volume control in other ventilator. So for today's session, we'll focus on the assist control using the volume control mode. The next button that they will ask you to determine is the trigger. Trigger is actually how the ventilator will be able to detect that the patient is able to take a breath, and if the patient, and this can be either through changes in the flow or changes in the pressure. All right, for this particular setting, we will actually just choose a volume through a flow trigger. Once you have selected, you just press confirm, and if you want to finalize your option, you just need to press accept. All right, so now that we are actually at the main screen that you'll be interacting with, you'll notice that this is a touch base with buttons at the bottom. The bottom half of the buttons are actually mechanical settings that you actually input. The central segments are actually the waveform that actually help you to actually determine how well the patient is synchronizing with the ventilator. And it's important the section to focus on because it helps you to determine whether there's any issues with how the mechanical ventilator is working with the patient. The top half is actually the parameters as you recorded by the ventilator on the patient's parameters. So it will actually give you the reading that is actually measured from the patient. Right. So the first thing that you want to do when you have when you go into the mode is to actually set the patient's parameter. So the parameters setting is all done in the bottom half, and we will go from the left to right to explain what these buttons means. The first button is actually F, or the frequency. That will be the respiratory rate that you set for the patient. If the patient has no respiratory drive at all, the machine will cycle every couple of seconds based on what you set as your frequency. So if you set at 10, every 6 seconds, the machine will actually deliver that breath. How you select the buttons, you can give a press, you will get highlighted. And once this is highlighted, you can turn the dial to change the parameters that you set. You also notice that there is a second screen that actually will change depending on the settings that you're above. This gives us a representation of the inspiratory and expiratory time. Alright, so when you are setting a frequency of 10, your respiratory cycle will be about 6 seconds. And the machine will actually tells you how much time is spent on inspiration versus how much time is spent on expiration. And that will give you the inspiration to expiration ratio. The second setting that you want to set would be what is your delivered breath, because this is a volume controlled ventilation. This means that we will tell the ventilator to actually target a certain pressure based on the flow. So how we usually set the tidal volume is based on the patient's ideal body weight. Remember earlier on you have set in a body weight based on the patient's ideal body weight. And typically for initial settings, we can actually target around 6 mils to 8 mils of ideal body weight. Assuming that this patient is a 70 kilo patient, 6 mils per ideal body weight would be 420. So that would be a reasonable initial setting to target. Right, so as usual, you press the button, you turn the dial, and it will come up 450. And the next button, the next section is to flow. Alright, this tells the ventilator how fast you want this tidal volume to be delivered. Alright, and for this particular settings, I will just put at 60. Right, you will notice that when we change either the tidal volume, frequency, and the flow, the I and E ratio will actually change. So let's say that you want to deliver the breath in a very, very slow flow, say 30. You'll notice that it takes a long time for the ventilator to actually reach the target volume, and the inspiratory time is now 1.52 and expiratory time is 4.4. That gives us an IE ratio of 1 is to close to 3. But if you want to deliver the breath much faster, at double the time, double the flow, you'll notice that the inspiratory time has actually shortened now, and that gives you a lower the ratio of 1 is to 6. Alright. T time is actually the time spent in inspiration after the delivery of a breath. For patients on volume control, typically we put that at 0. The RAM will tells you how the flow is actually been delivered. Is it constant, which means that the ventilator will actually deliver that flow in a very, very constant rate, or a decelerating mode, which is more physiological for the patient, which means that it's faster at the beginning and then it slows down. Right, so typically we'll put the RAM as a decelerating waveform. Next would be the flow trigger, which tells the ventilator whether the patient is trying to initiate the breath, and it can be determined by either the pressure or flow. So here, the higher the number, the less easy is it for the patient to actually generate a breath before the ventilator can detect. The lower the flow, the higher is the sensitivity. So the ventilator will be very easy to actually pick up a patient's effort. So a typical flow trigger we'll put at either 2 or 3. So we will just keep the setting as it is now. O2 is actually the oxygen that they're going to deliver to the patient. So it can go all the way up to 100% and as low as 21%, which is atmospheric air. So most ventilated patient, the lowest that we go down to will be about 30, all right, and can go all the way up to 100. Most of the time when you initiate a patient on mechanical ventilator, we will put at 100 first, stabilize the patient, and then titrate according to the patient's saturation. The last button that you need to set is actually the PEEP, which actually tells the ventilator to hold the pressure at the end of expiration. This will help to prevent the complete de-recruitment of the lung at the end of the breath, and it's very important in patients with hypoxemic respiratory failure to prevent the lung from totally collapsing. So typically we start off with at least a PEEP of 5 and then titrate according to the patient's requirement. So once we have actually programmed in the parameters for the patient, you'll notice that in the top bar, you have a set of parameters that actually is measured from the patient. And I'll go through these settings in greater details. The letter that you see is the C. C stands for controlled and is green. Basically, this means that the tidal breath that is delivered to the patient is actually initiated by the ventilator and not the machine. If this is a spontaneous effort, you will see that it turns to A, which means that this is an assisted breath triggered by the patient and fully supported by the ventilator. The next button is actually the peak airway pressure. This tells you the total airway pressure of the patient, and this reflects the degree of airway trauma that the patient may experience if it exceeds a certain limit. The third button is actually the mean airway pressure. And usual monitoring is not as important, but it tells you the average pressure in the airway system. The next button is the calculated or measured PEEP. Usually it's very close to the set PEEP that you have, but in certain patients with air trapping and auto PEEP, these numbers could be much higher, and that potentially can give you the warning that the patients may have auto PEEP. The next reading is actually the inspiratory to expiratory ratio. Earlier on, I have showed you how by manipulating the respiratory rate, volume, and the flow, it can actually change the ratio of the inspiration to expiration cycle. And this is actually continuously monitored and reflected in the reading above. The next button is the measured frequency. So in patients that is completely paralyzed, the patient trigger is actually entirely by the ventilator. So these numbers will be exactly the same as what you have set. But in the patients who has the ability to trigger, every breath will be assisted by the ventilator, right? And this reading can potentially go much higher than what you actually set. All right, so the patient has additional assisted breath is supported by the machine, so the measured frequency is higher than the set frequency. The next value is actually the measured tidal volume. All right, so this is very helpful in a patient where we are actually monitoring the patient respiratory mechanics. You have set the volume at 400, and there may be some variability in the tidal volume. So if you see that there's significant drop in the tidal volume, that could signify a few problems such as a leak or the air trapping. And it can also be very high in patients who are very dysynchronous and may be doing the double breaths. The next is the minute ventilation. So the minute ventilation is a calculated value by multiplying the frequency and the tidal volume. That will give you the total amount of tidal volume that is being delivered within a minute. All right, and in normal, the individual who's at rest, the average minute of ventilation is anywhere between 5 to 8 mils per minute. Okay, once you have this set of values, the next thing that you want to actually set is the alarm setting. The alarm setting will actually allows you to actually be notified when the patient breathes beyond or below a certain safety limit. And when you press that button, you will see that there will be a pop-up screen which allows you to set the alarm for the peak airway pressure, frequency, the minute ventilation, and the tidal volume. Alright, so if you leave it at the default setting, you potentially can see a lot of alarms which you do not want to be notified of. So the peak airway pressure is an important alarm for you to set. This will alert you when the airway pressure exceeds beyond a certain safe limit. Typically, we put it at around 40. You can actually change by pressing the button and then changing the dial to go up or go down. Alright. The second button is actually for the frequency. By default, the upper limit of frequency is put at 100. But obviously, you want to be alerted when the patient is breathing beyond a certain limit. And for this particular patient, the resting frequency is around 12. So I may want to set it around, let's say, 20. And the machine will alert me when the breath goes beyond that. The next button is actually the minute ventilation. As I said, the average minute ventilation for patient at rest is about 5 to 8 liters per minute. How I usually set the alarm is to have a buffer around 10% either above or below, and that will alert us when the minute ventilation exceeds the limit that I set. So sorry for that. Or goes below the limit that I have set. The next button is actually the tidal volume. Alright, so earlier on I've mentioned that a safe starting point is about 6 mils to 8 mils per ideal body weight. So if you want the ventilator to alert you when the patient is breathing beyond that, you can set the upper limit and the lower limit. Right. Once you have satisfied with the settings that you have put in, just press accept and this will be locked in. And whenever the patient is breathing above or below what you have set, you will see an alarm coming on at the top half, alerting you that this is a critical error and you need to attend to this patient immediately. So one of the ways that the mechanical ventilator can assist you in actually monitor the patient's lung mechanics is by displaying the certain waveform. In this particular setup, we have the pressure time waveform as well as the inspiratory flow time waveform. During the process of managing this patient, you may be actually doing certain respiratory maneuvers to actually calculate what is the patient's respiratory compliance and resistance. And very often, how we do this is by pressing the inspiratory pause button on the bottom half of the mechanical ventilator. Alright, when this is pressed, the ventilator will actually hold the breath at the end of inspiration, and the airway pressure may drop slightly, reflecting the true plateau pressure of the system. And once that is done, it will actually be reflected as the actual measurement of the plateau pressure, as well as calculate what is the patient compliance on the system. So next, we will actually demonstrate a patient that has very poor lung compliance. So you will now see that the peak airway pressure has suddenly jumped, and when that happens, you need to actually find out what is the cause. And again, you can actually do an inspiratory pause maneuver. When that is done, you will notice that the airway pressure has dropped slightly. And now you will see that compared to the earlier example, the plateau, the pressure has suddenly shot up, and the lung compliance has actually dropped. This will actually tell us that the patient's respiratory lung compliance has changed, and you need to figure out what may be the potential cause. So in this example, we are trying to demonstrate another phenomenon. You'll notice that in the waveform, the patient's expiratory flow does not actually goes back to the baseline. This would suggest that this patient may have some form of auto PEEP or dynamic hyperinflation. In order for us to actually measure what is actually the auto PEEP, you can do a respiratory maneuver by pressing the expiratory pause button. When you do that during the inspiration, you will notice that the measured airway pressure is actually much higher than the set PEEP, and they will also calculate for you what is the intrinsic peak of this patient. When you see this phenomenon, you will then need to actually troubleshoot what could be the possible cause, be it an increase in the resistance of the circuit, or whether the patient is breathing too fast, resulting in auto-PEEPing. To demonstrate another example of alarm that you may frequently encounter in the ICU. In this particular example, the patient is ventilated at a respiratory rate of 24 with a tidal volume of 400, and this is what is actually reflected in the patient measured tidal volume. Right? What has happened now is that you will see that the ventilator have started to give you a warning that the minute ventilation has actually dropped, and you'll see that there is a discrepancy between the measured tidal volume with the set tidal volume. So this is a situation where you have a mismatch, a low tidal volume that's mismatched with the set tidal volume, and you will need to examine this patient, the circuit, as well as the ventilator to see where is the source of drop in tidal volume.